Hello and welcome to all students. Now, today in this lecture, we are going to start a new topic, new unit of our syllabus. The name of this new unit is Linear Programming Problems. And in this unit, we see the mathematical formulation of linear programming problems. So outline of our lecture is, first of all we see some introductory part, then examples of linear programming problems, and then we will do some mathematical formulation of linear programming problems. A linear programming problems consist of business problems where faces several limitations causing restrictions. One has to remain within the framework of these restrictions and optimize. Optimize means either maximize or minimize as the case may be his goal. The strategies of doing so successfully is called solving a programming problems. We will be learning linear programming in this chapter, which is most widely used technique in production planning. Meaning of linear programming problems. As the name suggests, a linear programming problem is the problem of maximizing or minimizing a linear function subject to linear constraints. If the restrictions, when expressed mathematically in the form of linear inequalities, the programming problem is called as linear programming problems. In short, it is called as LPP. The restrictions are called as constraints. If the constraints do not have more than two variables, the LPP can be solved graphically. The goals, when written mathematically, are called objective functions. So these are some definitions we are using for the new words which appears while solving the linear programming problems. Formulation of linear programming problems. The easiest way to learn this concept is with the help of example. So let us take one example and try to solve this example. Let us take one example and try to formulate the mathematical model of that linear programming problem. So while solving this problem, you will understand how to formulate a given problem in the mathematical form. Let us take one example. Example number 1. A furniture dealer deals in only two items, tables and chairs. He has rupees 50,000 to invest and has storage space of at most 60 pieces. A table costs rupees 2,500 and chair cost rupees 500 rupees. He estimates that from the sale of one table he can make a profit of rupees 250, and that from the sale of one chair a profit of rupees 75. He wants to know how many tables and chairs he should buy from the available money so as to maximize his total profit, assuming that he can sell all the items which he buys. So for this problem, we have to write a mathematical model. So here a manufacturer deals with only two items, tables and chairs, and he want to purchase tables and chairs. For that he has only 50,000 rupees, and after purchasing he want to buy these chairs and tables, and he knows that the profit behind one table is 2500 rupees and profit behind one chair is rupees 500. So our problem is so the our problem is how many tables and how many chairs he should buy so that his profit will be maximum. So that is the problem that is the problem in front of the dealer. So to solve this problem, we have to write this problem in the form of a mathematical model. So for that, what we do is we write answer, mathematical formulation of the problem. Let x be the number of tables and y be the number of chairs that the dealer should buy. Obviously, x and y, they are the number of chairs and number of tables and number of chairs respectively. Therefore, x and y must be greater than or equal to 0. So x is greater equal 0 and y is greater equal 0. So see here, these are the conditions on these two variables. Number of chairs must be greater equal 0, number of tables must be greater equal 0. So these are the first two conditions, and these conditions are called as constraints, also called as constraints, and these constraints are called as non-negativity constraints. Non-negative constraints. The dealer is constrained by the maximum amount he can invest. So dealer has to invest at most 50,000 rupees. Therefore, and by the maximum number of items he can store is 60. Therefore, stated mathematically, so first constraint is if he buys x number of tables, then the total cost for table will be 2500 into x, and if he buys y number of chairs, then the total cost for the chair is 500 into y. Therefore, the total cost for table and chair is 2500 x plus 500 y, and that total cost must be less than or equal to 50,000 rupees. So this is our investment constraints, and if we simplify these constraints, if just divide by 500, you will get 5x plus y less equal 100, and x plus y is less equal 60, means total number of chairs and total number of tables, these number of chairs plus number of tables must be less than or equal to 60, because it has only a storage capacity of 60 items. So x plus y must be less equal 60. So this is our third and fourth constraints or third and fourth condition to maximize the profit of the dealer. The dealer wants to invest in such a way so as to maximize his profit. Say z, which stated as a function of x and y, is given by. So what will be the profit function? Profit function will be if he sells x number of tables and y number of chairs, then his profit function will be z is equal to 250x plus 75y, called objective function. So this is the goal or the profit function of the dealer. So mathematically the given problem now reduces to maximize z is equal to 250x plus 75y subject to the constraints 5x plus y is less equal 100 and x plus y is less equal 60, x is greater equal 0, comma y is greater equal 0. So this is the mathematical modeling of the given problem. Okay, as z is the profit function, therefore we have to maximize z subject to the 1 2 3 4 conditions. Okay, so this is mathematical formulation to maximize the profit of the dealer. So we have to maximize the linear function z subject to certain conditions determined by a set of linear inequalities with variables as non-negative. These are also some other problems. There are also some other problems where we have to minimize a linear function subject to certain conditions determined by a set of linear inequalities with variables as non-negative. Such problems are called the linear programming problems. Okay, so one problem, I have solved one problem. Now let us take one homework for you. Formulate the mathematical model for the following linear programming problem. So for you, I have given one problem. So at home, try to solve this problem. A company manufactures two types of bags, small and big. The raw material and labor available per day are 60 units and 50 hours respectively. Small bags requires 2 units of raw material and 5 hours of labor, whereas big bags requires 6 units of raw material and 2 hours of labor. It is observed that, however, they try the total number of bags produced per day not exceed 12. Solve the problem for maximizing the profit. If the profit for a small bag is rupees 50 and for the big bag is rupees 100, so for this problem you just try to write the mathematical model. Okay, so if you have any problem you can contact, you can write comments, and for paying attention, thank you very much.